Students, this is going to be the last part of chapter 5. This is a very short section, so it will finish really fast. It is going to be the differences between ionic and covalent bonds. Okay, now while I explain these differences, I'll also give you a recap of ionic and covalent bonds so that you guys are experts at this. Okay, so in terms of melting and boiling point. Okay, so let me make a table in terms of melting. Sorry guys, that's my girlfriend. Melting point and boiling point. Okay, ionic compounds, covalent compounds. Ionic compounds have a high melting and boiling point whereas covalent bonds have a low melting and boiling point. Now, there is a reason for this, obviously. Ionic bonds are, remember, between a metal and a non-metal, okay? So, there are strong electrostatic forces, okay? Electrostatic forces between ionic bonds, and these bonds are usually hard to break. You need a lot of heat to break these strong electrostatic forces. Therefore, the melting and boiling point for ionic compounds are high. In terms of covalent bonds, they have a low melting and boiling point. This is because covalent bonds have weak intermolecular forces, which are called van der Waals forces. We talked about this in, remember group 17 guys? Was it group 17? Yes, halogens. So, covalent bonds have weak intermolecular forces, and only a small amount of heat is required to break them up. So that's the first property I wanted to talk about. The second property is solubility in water. Let me do this on another page. Solubility in water, and solubility just means the ability to dissolve. Okay, so ionic compounds, this you should really memorize guys. Solubility in water, ionic compounds are soluble in water, covalent compounds are insoluble in water. Okay, solubility in organic solvents, it's the opposite guys. Ionic compounds are insoluble in organic solvents, whereas covalent compounds are soluble in inorganic solvents. The last thing, electrical conductivity. Ionic compounds they're able to conduct electricity, but there is a catch guys. They are only able to conduct electricity in molten and aqueous form. And what does molten and aqueous mean? This is everything about chapter 6, electrolysis. Electrical conductivity for covalent compounds do not conduct electricity. Okay, and you don't have to say anything about molten or aqueous because covalent compounds do not exist as in molten or aqueous form. So that's about it guys. Really, I'm very happy that I'm able to cover this chapter. Just a quick recap: ionic compounds between metals and non-metals. Okay, covalent compounds between non-metals and non-metals. Covalent compounds are the ones that have the single bond, double bond, triple bond. We know triple bond is for nitrogen and phosphorus, double bond for oxygen and carbon dioxide, single bond for sodium chloride, for hydrogen, for tetrachloromethane, for ammonia. And how did we form our ionic equations for ionic compounds? Remember, if you have, for example, aluminium chloride, so Al3 plus and Cl minus, you would get AlCl3, and the equation for aluminium is going to be aluminium metal becomes aluminium ion, Al3 plus, because we have a 3 plus here, 3 electrons. Whereas for chlorine, the equation is going to be different slightly. Chlorine plus an electron will give you a chloride ion. For both these equations, the ion is on the right hand side. The only difference is that for the metal, the electrons are on the right hand side. For the non-metal, the electrons are on the left hand side. The plusing is switched, okay guys? So go over this stuff and I promise you, you'll be good to go. Thank you guys.